Good afternoon, everybody. We are our team. This is Kamila, Antonios, and Ilya, and myself, Agata. And we are in TO studio. We are proposing. We are proposing a new model for the urban environment, a behavioral system based on low-level individual rules and the complex relations and interactions between the members towards self-assembly, self-structuring, adaptation, and reconfiguration in time. An urban oncology of dynamic communication, participation, and coexistence between different populations and systems that blurs the distinctions of artificial and natural, and opens up the possibilities of emergent body articulations and space organizations based on singular and group behaviors. Inspired by the phenomena of nature, we gain to create a system in which agent residing on the scale and start producing behavior that lies one scale above them, displaying itself emergent movement from low-level rules to higher-level sophistication. Referring to architectural qualities on the inflatable and pneumatic proposals of the 70s architects such as Recurrent Co. Or Fuller, we believe that architecture must be active and interactive by challenging the notions of settlement and incorporating mobility without architecture. The initial research focused on nature giving notion of mobility, reconfiguration, abilities through constructional games through constructional games and toys, and recent development of soft robotic abilities. The initial primitive creatures in such a system becomes the basic for the evolutionary game that address two main characteristics: mobility capacity, aggregation ability through an open-ended growth procedure. The system itself is composed of soft-body pneumatic robot unit whose transformable anatomy gives the multifunctionality, flexibility, transformability, and mobility to entire system, and it is a key to structure architecture formation. The unit is composed by rigid segments, spherical joints, three independently air inflatable tubes connected by elastic rubber. The system gives both the potential of straight expansion and construction. Inflatable techniques we worked with give us required flexibility and capability for specific transformation, which was always required in our scheme. Although the intelligence of this unit is limited to control only its own locomotion, produced hybrid model can achieve various states and behaviors except from stretching and shrinking. Unit is able to roll, bend, jump, twist, or pull up. Incorporating mobility gives the possibility to create active, interactive architecture, able to engage participants in real time.
So as already noticed, our smallest element of the system of ecology is a unit. And by having this incredibly flexible muscle, we're able to control reconfiguration of the unit, which gives us a possibility to have infinitive amount of states of the unit. So it's not finite state unit. And by sequencing this control of each muscle, we're able to achieve different kind of motions and locomotions, but the most important for us, it's mobility. So to push this further and we developed the full-scale prototype, which has inside a system to control all this air actuators. And first development happens on the muscle as well. So muscle got the second state of existence, which is deflation. So muscle might be rigidified by creating a vacuum inside of it, and due to special construction of muscle chambers, they're able to keep keeps all of these lines rigid. So all of this allows us to build up the prototype, which is able to navigate in an environment in a controlled way, So as you see, it easily goes force back, and it's able to turn, but we not introduce it in the model. But by changing the radius of each of the spherical parts of the unit, we're able to make it turn. And another problem of the prototype was make it autonomous, which pushed the mobility aspect much more further and like created true mobility. So autonomy is achieved by internal system consists of compressor and a couple of air tanks storing airs and storing negative pressure inside. So system both operates in positive and negative pressure. And as well, all these controls happen by 8 valves. Each valve has just 2 states, open and close, and those states are controlled through the time, which allows us, by no timing, control the expansion of the muscle. So this is the development.
Autonomy implies energy consumption. Therefore, for the system, must be able to gather energy by itself when required. As a responding strategy for this problem, we develop a soft deployable membrane, which is an important part of the unit, and has solar panels embedded, working as an energy harvesting. The deployable membrane is also crucial when more units are connected, because by self-deploying creates space enclosure and can self-structure. The soft membrane in the physical prototype is actuated indeed using inflation, which allows it to open up and deploy. Mobility gives the ability to high population of units to search for their neighbors and connect to each other as a collectivity. Each unit can sense the space. The system constructs goals and can learn over time because it's durational and relationally based. We in fact want to move beyond the idea of architecture as a fixed and finite and towards a more dynamic and evolving concept. Physically, while the air is pumped in the muscle for the unit movement, the air is sucked out at the stream, allowing a vacuum connection. This means that when we can control the power and the intensity of each connection and maintain them in a specific configuration. When they are connected, air cannot pass through, entailing the system discontinuity and guaranteeing each unit its own separate metabolism. In this way, they can act independently in the reconfiguration process. A single unit has 2 suction cups located in the exterior hemispheres and can be connected to maximum 6 other units simultaneously. The possible connections are regulated by varying angles from 20 to 60 degrees when the suction connects directly to another unit's hemisphere, and 180 degrees when it comes to linear suction cup to suction cup connection. When they're joined to the hemisphere, they don't need additional forces, and by moving, they adjust in position by themselves. When 2 units are connected, they work together as a whole body. In this video, we can see how sucker can set to the ground or to any appropriate surface and can create fixed anchor point to lift themselves up. By using these assembly rules, units are able to come together and create some basic 2D linear aggregations. Here we can see some Y-shape and linear connection that are the basic entity in our taxonomy. This basic aggregation can move themselves easily, collectively, forming 2D branching and radial patterns at ground level.
The attributes of our unit, through mobility and connectivity in numbers, are distributed intelligence, consensus sensing, and decision-making necessary to accomplish goals beyond the ability of the individual. Structure and unit deployment behavior are cone-dependent. Local ground formation is based on the unit reconfiguration and combination, following a continuous feedback between rules and goals. The choreography and dynamic logistics in the system for deployment and structure on ground plane with different body plans is based on the states of the initial minimal units, the types, the sequence, and the selection of the next movement. The growth tendencies and organizational patterns that emerge becomes a game of genotype sequence between the participants. 1, 2, 3 connections or an interchange between the generating ground plane organization designate the tendency of the whole accumulation. In sequence of 2, the emergent pattern of the population is tree-like, starting to define borders of space where number only defined bifurcations. The control of interchange gives the possibility of introducing local branches in the process of growth where is needed and various outcomes of the same inputs. So the free movement of the unit and connection possibilities form new body plans of higher intelligence and emergent behaviors in an evolutionary open-ended procedure. The body plans are classified in 2 big families, the walkers and the linear bodies. The communication between the unit and connection possibilities between the units in this new order lead to radical new locomotion and self-assemble abilities. For example, the tribal can walk, rise, stabilize itself, pass obstacles that the primitive unit could not be able to do through the harmonic sequence of deflation-inflation of the muscles. Parts are cooperating, are steadily sequencing their internal mechanism to achieve a new common goal through communication. The introduction of new units to create more complex creatures is not only a quantitative issue, but rather a qualitative difference where each part is uniquely connected to its neighbors, leading to emergent abilities. By the reconfiguration of the bodies of the linear creatures, depending on their number of units, leads to different forms of locomotion, allow them to crawl, roll, curl through their body configuration and inflation sequence, and also to use other structures as infrastructure of deployment. Linear bodies that are already attached to the structure participate in the reconfiguration and self-assemble process by passing around other units and body plans, and also are able to entangle physically to lift others from ground. The free organic movement of the linear bodies also allow them to pack and position themselves inside existing configurations in one-to-one relations and constant procedural reconfiguration. Here we see a linear body, how it curls and tries to entangle itself, and different configurations, how they pack and go inside different formations. This is some examples of how they can form different kinds of closed space and how they pass obstacles and how they can populate an infrastructure. So, formation in the Z direction can be made by using all these abilities of climbing and using the free appendixes. When a body plan meets a free join, it's aware either to continue ground level growth or climb on top of it by an input parameter of capacity of the next level. Temporality is also very essential in our system because it accommodates the ability to disengage to start the procedure of structuring in a new area. Different capacity input influence the density areas and follow the emergent tendencies of the self-organization. Increasing the population also increases complexity of interaction. Cluster of body plans in the face of aggregation can signal others and recognize the suitable point of climbing on top of the existing formation. Parameters like deploying different type of body plans, different capacity of connection, and aggregation lead to vertical or horizontal distributions. This exploration allows us to create generative aggregations that pack and stack on top of it and involve huge number of creatures. However, a group of them can already create a variety of medium or small size formations that accommodate and initiate different types of behaviors and occupancy.
As mentioned before, unit can expand to double its length and also can lift itself. Using these abilities, members of ground plane organization are able to create internal tensions. When unit extend, it creates forces that push against each other, and this tension leads to raising structure up. Following principles established on connectivity in ground-based network, we generated numerous superbodies that can be formed on ground plane in various configurations regarding the numbers of units involved. And they can be categorized in the group of different patterns according to space-making strategies, such as closed geometry mesh, open geometry mesh, and completely random mesh. These formations may be achieved by singular unit or body plans and gain to create optimized strategy for spacious formation. Very crucial for the system is to establish sequence of anchor points along perimeter, and those anchor points must be fixed. Because this system is discontinuous and unit has ability to reconfigure within the formation, we can also achieve tension in the system by moving anchor points in formation. To be able to raise different formations, we need to equalize the tension forces, as this gives a stability within the structure system. In order to elevate structure higher, we need to build more complex formations, as it gives more possibilities for having sequential operations. Within the mesh that is more subdivided, we need firstly recognized boundaries of our cluster, and then the process of elevation is initiated from the center of formation and through a sequence of extension of the unit, and simultaneously releasing of anchor points which are repeated and radiated on the perimeter of the cluster within mesh. Other method starts from periphery, from the formation, and this type of operation is less successful, as to achieve similar results of popping up, we need to add another unit that will assist the structure.
The very crucial for our project is those all formations and scales mentioned, they operate all together in one scale. So, for example, the body plans are able to fuse a couple of domes in order to create a bigger space formation, as well as create some column-like formations to support the structure. So the lifespan of the system is considered to be like localized on some areas, since the unit's unable to move far away from the space, and it's included communication between all of the units and members of the ecology, how they participate between themselves, how they found the appropriate areas to start aggregation of formation, and how they create body plans to be able to pass obstacles and other as well as how they're able to aggregate on the existing elements of urban furniture, anchor themselves with some light bulbs, for example. So basically, this kind of behavior of the unit and of the unit itself is supposed to fuse like the edge in between robotics and people. So people don't treat robots anymore like something like aliens for the city, and they're supposed to cooperate and exist in one environment like two ecologies. Thank you. So here on the table, we see some basic studies about popping up structure, body plans, some space formations they make, as well as a development of the unit and muscle itself. There is a formation shows how skin gets deployed and like create an enclosure around the space. This unit is the main one, which is autonomous full-scale unit. And those guys, they, as a model of communication within themselves. As well on that side, you see some early models of the things. And the very last thing is the small formations, which you can rearrange.
I'll just jump in. I mean, it's a sort of a brilliant project. It's so kind of it opens up so much terrain, I think, which is I find it really compelling. I have a couple of questions, in terms of your thinking, because I think there's a lot of behavior that's being sort of animated in a way in your simulations, and it's not clear yet for me how these things are actually self-aware. I mean, we've seen some of the drone projects already that they're really struggling with trying to understand where they sit in space, in physical space, and I'm not totally understanding yet precisely how that is happening here, because I think it'll have a lot of implications for how the system really can be, in fact, sort of intelligent. How do they actually understand what the rest of the ecology is doing? Is that even kind of necessary? And I know you're showing animations that sort of you know, make it appear like it won't matter, like it's as if it's a kind of a slime mold or something. But in terms of some of the drawings you're showing, it actually might matter, right? There might be some other stuff at play here. Cross communication with human beings, with program, with other stuff is going to become a kind of a critical part. I'm not totally sure yet where the kind of feedback is kind of happening, besides this being literally just a kind of an autonomous system that has its own logics that are kind of separate from human logics. I'm curious a little bit about what your take is on that. And I love the point at the end, and maybe I kind of missed it precisely, but I think you were saying that in the future we won't be sort of threatened by these things, right? They'll become sort of everyday parts of the kind of the city. Like squirrels, you know, playing in the park, or birds in the trees. These things will just be sort of moving like across the city. So there's certainly an attitude about them being accepted, but I want to know a little bit more about that narrative, because I'm kind of fascinated by it. You guys are allowed to speak.
About the self-awareness, it just simply breaks down to super low-level rules. So the units are able to understand environment by just understanding the neighborhoods around them. So they just don't know about all population which exists around them. They just know like a couple of neighbors around. And as well, they are able to recognize just the surfaces according to which like they operate, like use some sensors. And initial self-awareness is just the states, like the pressure in the muscles itself, which gives them information back about what they kind of can perform right now. So if they kind of push in some structure, it's obviously the pressure increase, and they monitor how much pressure they give and how much expansion they get out of that. The last point, yes, we truly believe that architecture should go more into emotive kind of like participatory thing, which means that like the space creation is not like the space creation of making some boxes and kind of stuff. It's something which human also in that, and it lives inside of that, and it gets some emotional aspect out of the thing.
Just to continue on the acceptance in the environment, I don't know for anyone else, but I had some flashbacks of a Korean colleague trying to have me eat these worm-like street food. So it scares me a little bit to see this pile of things. No, but having struggled on the muscle tower at MIT for an entire year to control this properly, I really want to emphasize how crazy it is, what kind of control you achieve just with actuators. So you not just bend it, but you have them roll, you have them pick up and so on. And that is really impressive. And you just presented it as if, yeah, you developed it quickly, but that is really, really, really impressive. One could make a few comments on when you try to go to more larger and structural kind of things, their mechanisms, and so they depend entirely on the moment connection of your suction cap, which probably cannot take these kind of things. So there perhaps you take a leap that is a bit beyond that, but let us not go there, because I think there's a lot of more interesting comments to be made about the behavior that you developed. So really congrats from my part. Yeah.
I want to say something also, because I was so nasty in the last presentation. I just want to say it's amazing. Amazing, amazing, amazing is beautiful and so sexy. And it's beautiful how you presented the rigor that is behind, but also the kind of aesthetics of it. And really, I think that this is the project so far for me that has been more connected to the studio agenda. Because it happens, the behavior is in the one unit, but also in the collective and in the performance. And so there is so many levels of this behavioral complexity that are at play that I think that you have to be commended for it, really. There is many, many, many layers in the project that I appreciate a lot. Having said that, the one one thing that I think we saw more of it in the phase 1 presentation, and that today I'm missing maybe a little bit, is when the units begin to work with one another, to crawl onto each other, to basically achieve this complex behavior. Today you presented it, of course, but I think that at the end the project does not stress that enough. If anything I can say about it. And I would like, because at the end they kind of aggregate in this Bedford Square very much, in a way, very similar to the previous project, funny enough, when in fact you have so much more complexity in the behavior that I would expect the kind of aggregation to be also of a different kind. That's maybe the one comment. And then the question of scale. The crazy thing about, and now this is one-to-one scale, okay, but it's so interesting to think about the radical shift of scale that this could have as technology becomes smaller and smaller and smaller, that suddenly the worm is actually the same as this, with the same kind of complexity in it, that I can send it to my back to scratch my back when I need to, or that this is actually becoming a whole building, or a whole room, for instance, that could crawl with others to aggregate in different ways. I find that so interesting to think that really this is the one-to-one, but it's only today that is one-to-one, really. So, yeah, very interesting project, really.
Yeah, I have to admit it's most impressive. And I think it allows us to enter a very, very exciting space of research and development in terms of the robotics, and also the element of artificial intelligence as an embodied and evolving intelligence, which there's, you know, some people think that this is the way forward for generating artificial intelligence as part of an artificial life process, which needs to be embodied, which needs to be exposed to environmental conditions. And I think the question of swarm roboting and learning heuristics, I think, would be something, would answer to some of Jason's question. And there has been research going on where the various experiences and feedback mechanisms which each of these is making could then instantly shared with the whole population. That's what accelerates it so much more than what you would have with individual learning and development or even evolutionary processes. They would be embedded and shared across. I think that's something which could be investigated. I mean, the question of self-awareness, or what are actually the sensors, and what is picked up from the environment as a feedback, or as a resistance, and as a piece of information, is very interesting. You said there was the internal states are known, and the sequencing of internal states. But you know, what are the external information which coming in? Is it only through them? Is it only the vestibular sense? It needs to be a sort of balancing. Is it also vision or touch? These are very. I mean, you have that suction cup. There is kind of connection with outside. We talked about degrees of suction relative to something. So I think we're just touching that world, which is incredibly interesting. And how do you then represent that and work with that in the simulation, and you know, you need to kind of simulate, and that anyway the simulations always do that. This kind of abstraction capacity of the piece and organism needs to be unfolded in the simulation. I really like. I think there's a lot of course, what all this robotics looks at is a biomimetic research agenda, where we need to look at you know, simple organisms and collective organisms. What was exciting here is precisely again that body plan, condition, and the various aggregations, and building up into a collective organism, which has then temporary differentiation of the element of capacities. So that's, I think, very, very exciting thinking. And in terms of bringing all this into architecture, I really love that these images that we could think of little pavilions and buildings having that animation and interaction capacity, which is in the first instance easier with a little toy and pet, but that a little pavilion could be kind of pet-like in this way, and have that interactive intelligence. I think is you calibrated the researchers think in its projection really, really well and to the point. So maybe one last point, which I thought, which you find, which goes to all the projects which are on the table with respect to Theo's world is, and I respect that, the restriction to a single base unit, and with the body plan generating the creature variety, and that's something this year which is much more interesting than last year. But it's still I think the next role for me would be introduce a second radically different creature and the symbiotic potentials, the different concentrations of the populations and what would come out of that. A to A in various ways, and then but also A to B in various concentrations and B to B, because yeah, I think there will be, you know, you have here already something quite different. You had to integrate into the piece, but these could also be separate creatures, and you have a symbiotic population and ecology, just as a hint. But I mean, the world you're opening up is monumental, and why is that so important? And we knew all about this, but that this is actually happening here in the building, and that we're kind of cracking hard problems and making a contribution is really, really inspiring.
Just to be... No, let me just say, I think, you know, it's not just that it's happening in the building, it looks like it wants to get out of the building. And I was imagining, like, the only technical issue it seems like you haven't presented today is how they got to the door handle to get across the street. But I'm sure you're actually somewhere in your incredible encyclopedia of work, you've actually solved that problem too. I think the one point, I'll applaud it like the others have to this point in terms of the depth of its rigor and the world it opens up. The thing that I'm struck by is this point that Patrick just alluded to, which is what's the job it has to do now. And in a way, it feels to me like you've developed a thermonuclear device and you're asking it to, like, trim a shrub. Like, to give these guys the job of making a pavilion seems like an insult to their intelligence at a certain level. Now, I know why you did it, and I can accept to a degree the idea that that becomes a baseline by which to measure success. But in a way, it seems like what you would be arguing for is that that very definition or that criteria should be emerging more from the project and not an application of known, in fact, century-old assumptions. That architecture is pushed forward, just as Mies would have argued in the 1920s, by making a Miesian pavilion. And your worms can do that, but I think you've got to acknowledge then that what you're also reaffirming is a modern architectural culture that I would say your not just your interest in behavior, but your definition of a brick is absolutely trying to eradicate. And I think any moment in which that slips in as an assumption is something for you to argue for or against. I think your machine, what I love about this part of your picture is that there's a group of your project pieces that aren't on board at all. Like, these guys want to just hold on to the signpost until apparently a taxi goes by slow enough they're going to jump on and leave Bedford Square. And I think you've got to acknowledge that and argue for it. Because in a way what you have then is both sides of the equation. You have the definition of a disciplinary project, i.e. the development of new materials, like Mies argued with glass and steel, lead to new form. But on the other extreme, you have the possibility, in fact, the discipline itself needs to be left behind because these kind of bricks no longer want to ask the same kind of questions that architects have long asked of it. And I think that's an astonishing thing to see in it, but I think it's really something to embrace and to claim as a kind of result at the end. I don't think you can be ambivalent on it, by the way. Those are two radically different positions, and they're camps that are at war with one another. That architecture is actually, at a moment, despite all of this intelligence and material, needs to go back and reassert its same old familiar property, that we're going to make a pavilion. Once we make a pavilion, we'll make a better building. With that, we'll get a planning sensibility. Or on the other hand, a completely different kind of project that will shed the built structure itself, even as a definition of the realm that we want to work in. I think that's just a terrific achievement in it. But it's got to be articulated and argued for, I think, and not just assumed.
I mean, I share both of the last two comments, opinions, but I just want to speculate a little bit rather than critique so much. I think there's two ways I see the project moving forward. One is in terms of software or firmware, if you want to call it that, and the other is in terms of its physical body plan and the way it can amass and do useful things. The first one, I think, out of all the projects in Theo Studio, this project is not geometric in the sense that it's not about an aggregate base cell that creates closed geometry. And I think that's a really important distinction, because suddenly it's actually the movements it does, the configurations each one squirms into, that allows for different things to happen when you put a whole group of them together. For that reason, though, I also think these nodal connections is not perhaps the best way forward, because that's when you start to deny its body plan, whereas, say, where Brett pointed out, the amassing of them, almost like caterpillars do on trees and things, there's a critical mass. What can they do when they're a critical mass? So from the hardware side, you know, they're very scuba-esque. And if you think of ant bridges, there you have an individual ant that's not that buoyant, but when they cling together as a whole bunch, they suddenly gain buoyancy. And I think that's something you could consider, like maybe the idea of how does an amassing of these actually produce something? Because at the moment, you're treating them just like a brick, and I don't think that's the right answer for something that it's not really designed to interlock in the same way that bricks do. So that's one aspect. And the other is in terms of machine learning. Dr. Lee, a roboticist in Germany, is working on how machines learn through the body they're in. And I think, you know, out of all the projects in Theo Studio, because you have a specific body plan, I think this is something that needs to be interrogated, and it's an exciting way forward. Like, how does an individual gain a certain level of self-awareness through its body as it acts and behaves in the world? And then if you consider, say, a multi-organism body, is there a further level of awareness that they're gaining when they're together? So I think there's a lot of potential for it, but you really have to shift it towards the kind of questions it can answer rather than trying to force it into the domain of, you know, like traditional tectonics.
Can I just add, I'd really like to say that I've been really impressed with the way you've gone through the process of this, the way you presented, the work you've done. It really is just fantastic. I'm sure everybody will agree with that. And for me, you've actually tackled the most difficult part of engineering side of things. There's a lot of work being done in terms of artificial intelligence, in terms of software writing and all that. But the biggest issue here is that how do you deal with bone and muscle? In terms of nature, moving creatures needs two. They need solidity and they need a muscle. And for a long time, I think it's what you mentioned about what's been done at MIT, everybody's sort of avoided that. They've all gone into deal with the software side of things. To me, that's the easiest bit to deal with. How they self-awareness, how they communicate with each other, that is the easiest. I mean, Siemens at the moment are actually taking all the gadgets, electronics for self-drive cars and trying to reduce it into one single box. That's fine. But who's dealing with the issues? And I like the way the process you've gone through is incredibly logical. You went through your early prototypes. You understood the fact that you need a frame, you need something that will move, which is your balloons. You're using pneumatics, which is probably not the easiest thing to use. And you've put together a form. And the only thing I'll say is this form actually helps you to achieve what the brief that the school requires you to do. But you can actually create a number of forms with this. As soon as you've actually created a muscle and a bone between the plastics and the movement part, then you can create a number of forms. Which means, coming back to your comment, the whole idea of architecture becomes secondary. So I would like to say it's brilliant what you've done. I really do enjoy working with you on this one, and I really do like the way you've presented it, and I think you can actually expand it beyond architecture, engineering. It's another, it could almost become another form of creature that we all see walking around London and everywhere else and doing various things, going down, not just scratching somebody's back, but exploring the depth of the sea or whatever. It's brilliant. Thank you.
I think almost everything's been said. I just want to leave two provocations in a way of you to, in the next 2 weeks, potentially reframe or push up against these filters. One is that you could put this in the domain or the conversation about reprogrammable materials, that suddenly as an aggregation you would have something that could change its bending capacity, its air permeability, etc., which is picking up on Patrick's comment. And the last one is that this thing actually is pretty skillful, so it could be more than just the brick, it could also be the builder. And then somehow this kind of collaboration with site conditions and other materials could actually become a rich way of thinking about not just a building made only of these things, but a building made by and consisting of these things and other stuff.
Just, I mean, in terms of a small point from my side, I think the body plan is really where at the heart of all of this kind of intelligence it really lies. And it builds on this kind of much more evolutionary paradigms of endless forms. What happens when you introduce a new segment into the body? You have a taxonomy of possibilities and potentials. And I think that's where you need to extract some of these things and to understand behavior in all of its levels and magnitudes of influence. Because what I really love about the prototype is it's one that actually demonstrates an interior a metabolism of an individual element, and then how it calibrates itself as an individual unit completely transforms when it starts to have these kind of cooperative participatory practices in developing next level of intelligence. And in terms of everything being addressed from a software side, even the notion of one of these semispheres being touched down onto the ground, where that now becomes an activation, and the difference between a two-legged creature or a three-legged creature now already is starting to give information that's localized, but somehow can then be embedded within the way that this thing monitors. And I think if you see this as a progressive evolution, and I agree completely with Brett's statements about shedding the idea of architecture, but maybe this is a provocation for a commission for us to do outside. Because I think in some sense it's not about even robotics. I think this kind of disciplinary division I think is really important. I like the statement of the emotive capacity, because we will fundamentally have to rethink our relationship to machines and infrastructure. And Jason, just to mention, like, it's not a narrative. This is a reality, this is today, this is stuff that we are fundamentally, like, I am very much, how can I say, I really am a believer in this stuff, but you could say whatever you want. That's my personal problem. But when I see kids doing stuff with a laser cutter and nothing, and developing things that MIT gets a lot of money to do, yes, then you kind of say, like, it's not even about architects looking at robotics. It's architects changing the game and finding new ways to introduce a value system of how we think through things that are spatial. I think that there has to be a kind of conviction that this is beyond novelty, but I think novelty is important, because for here, when we talk about communication, really trying to see this as an ecology of machines and people means that their behaviors, just like our behaviors, will be signaling. It's not even on and off or red light means go, stop, whatever. It's going to introduce different ways of the way that we facilitate that stuff and how we can kind of participate in it. And I really do think, in terms of the studio, it's not even about one project. So if you couple this with the research, let's say that the first team was presenting today on machine vision, we have to kind of see that that's really the new DRL project, is bringing these all together and actually seeing them that it could be deployed as an ecology of machines to create, I think, a very new kind of terrain. It's beyond architecture in its simplest form. It's beyond engineering. And I think these are the challenges, and that's why we bring you guys in here, to help us to really speculate on that, but speculate with a way that they can demonstrate that they have the accountability to actually work on the problem. It's one thing to animate it.
It bears on this question of what to do in the next 2 to 3 weeks to now summarize a brilliant body of work over the last 16 months. And I would say that goes back to the origins of the studio, in which you could say 15 years ago, we had an ambition in creating a collaborative design studio in which it would be a kind of open model. We required that all the teams upload and share files and all original file formats on a server that then became accessible to everyone. Some people stole stuff, some people ignored the whole thing. What's happened to that 15 years, though, which I think is something you should be speculating on with how you want to resolve it at this point in its research, is, of course, the rise of intellectual property that at the other extreme is now trying to lock up projects like this from the top down, and i.e. that the four of you are in command of a design world that you've set that no one else gets access to. It can work at either extreme. Your conclusion at the end of phase 2 could be to simply upload all of the instruction sets that you've created to everybody in this room, some of whom in phase 1 now are going to do a better version this time next year, by taking all of that and building on it. Or at the other end, let's say, it would be completely reasonable for you to say, I'm going to lock down the few key pieces of knowledge that's been produced out of this, and I'm going to protect them. We've received patent applications from graduating DRL students who are quite happy with that model. They want to own it. They've invested 1.5 years of work in it. It's theirs to push forward. The comments that have come out of the discussion right now are assuming you're going to continue work on this in a very stable, familiar form. You're the experts of it. It's your job to now answer the questions. One of the consequences of this project could also be actually that you want to now let anybody in a room like this speculate on what the different behaviors might be, what the different arrangement of rigid and soft parts should be, and it would be releasing all of that. And I think you're in the unique position to actually claim what that answer should be in a project like this. We live in a world today where either one is clearly totally viable. And I think
there's a third one, which is 15 years later, I think the program has matured a community that can actually take it on board as a project that really does continue. Because I think the authorship of this, of course, resides in some people, but it also resides in the responses to the other projects, the tutors, the people that are working. And I think that that's where this is really going to evolve, because what is really important to understand is that some of these kids now are really coming back into the studio because of the desire to do this, because they don't get it at Heatherwick's office, and they're not going to get it in the practice. But the nature of research, I think, is really important to actually continue to filter, and that's something that we should kind of invent a new model. Because if they sort of upload this kind of stuff, maybe at best someone reads this, but actually this is not so important. It's actually the thinking and the intellectual work that's being driven through working through these systems to be able to upgrade it. So 2.0 of this may actually take a radically different form. Miniaturization, like Mark was saying, may offer a very different sensibility on that project. And it's just trying to find a way to make that part of the continuing project and something that we're always trying to work on here. And I think the open door process of the AA allows that to be better than most places. But it's trying to really be creative about that methodology, extending beyond this way. We don't have solutions, but I think the community is actually a provocation, but it's a provocation to the community to continue with each other.
I think that just to maybe say something about this, is that what I find amazing about this project, and of course about all DRL work in general, is the fact that architects expand so much out and far away from their own discipline to actually bring it to do the work. In this case, we go into robotics, we go into a lot of different territories in order to make this happen. And what I find always a kind of a strange moment is this willingness to bring this back into the architectural realm, when in fact it is now situated also in a place where you could invite other disciplines to think about, okay, this is the work, what should we do with it? Because when it goes into miniaturization, then I'm sure that other disciplines see this as an incredible potential versus the possibilities that we see in architecture. And then I think the discussion about, is this an open source project or is this a patented project, would also be part of those discussions, because it depends on which discipline you're talking with. So I think that if you keep it in architecture, definitely it would be wonderful if it was open source. Otherwise, there is no future for it, almost, you would say. But if you go into another discipline, maybe the discussion is different. So I think that it would be very, very, very interesting to investigate, to ask for other disciplines to look at this work and investigate potential avenues that it could take.
I totally agree to that. Actually, I was before in the presentation I was asking for like what is the benefit for the urban environment for us as humans. In this project, the first time actually, I thought we could follow different strategies to say it's an open source project. The only thing that pops up is maybe an app store, an iTunes store. That is also addressing the question of authorship. I think it's not about the hardware, it's about the applications, and that has, the idea. How can that become?
Really fundamentally changed. It's kind of like the belief that we've taken it as far as we can. But if you think about the studio culture, that is an open source platform. When we see generations to generations, that has an influence. When we do this in a live event or share it, it's not because we're saying that this is going to market. I think the fundamental motivation about it is actually driven with a very different desire. I think the open source aspect is that there are really a lot of open source users. So to contribute is to really be able to flush out where it is where this intelligence really resides. And of course other people should be brought in, because I'm not sure every student can actually upgrade this kind of prototype. And maybe that's not really what they're supposed to be doing, but I think it is a provocation to find better ways to be strategic about it. And that I think makes a demand on all of us to actually speculate beyond really the finite tendencies of the way that we operate.
Yeah, I mean, I'm definitely questioning in some level the generative model, say, for the project. I mean, we're talking about potentially a super organism of high level intelligence. And you have a rendering of your project with a person and his baby. And I know it's hard to train a dog to sit, and it's very hard to sort of train a 1-year-old to be polite. So one can imagine, and I'm just sort of thinking like in a 10-year term here, who you need to bring in, and I think it has a lot to do. You're so in control of the machinery at this point. I wonder about inputs. It's more in the realm of human-computer interaction, and getting the machines and the humans to actually begin to have a kind of a productive conversation and be able to sort of, communicate in a productive way. I mean, for me, that is really a complex problem, and it would be a really fascinating, I think, next step, so that isn't such a passive, it could be this kind of radical interaction, and that could be a very interesting next step.
Yeah. I think the trap in this discussion is still the attitude that architecture is a profession or a discipline. Although that's obviously a constructive thing, it also works against it in a way. Like if you take, for instance, any technology startup, it's a group of people all with different skills, all working in complementary ways together. Yet the architectural practice as a model, it's almost dead in that sense, I would say, that this idea that you can work in isolation or that you need everyone of the like mind and the same skills. I mean, we don't even operate that way anyway. I mean, we have structural engineering consultants that work from day one on projects, a whole range of consultants. So I think this discussion's a little bit zoomed in too far. I don't think we have to speculate too far to know which direction this should go.
I think for me it's very important that I defend that these things aggregate into some kind of space-making condition, and that this is research which feeds back into the discipline. This is not per se a robotics laboratory which doesn't mind in which direction these things spin, whether they become vehicles transport systems or other forms of machinery. We care about that this is contributing and revolutionizing architecture, which can be the societal purpose of which, or its particular societal task in the differentiation of professions, can be formulated with a sufficient degree of abstraction. I would say, the ordering social processes through spatial devices, which don't necessarily need to be always, enveloping with respect to thermal separation, but they are space-making substances which guide, gather, and structure specific situations which are territorially rolled out, distributed at particular locations for certain forms of interaction. That would be relatively abstract, but definition of it, which we have to awareness and consciousness of, to make the contribution to architecture and its evolution. That's our responsibility. That's why we've made certain choices, and we're sitting in a particular institution, because as a pure robotics project, of course, a lot of these things are drawn in from robotics research. If we would have to situate it there, it would lose its originality to a large extent. Or then, although I agree that specific of the problematics which come out of architecture, also push forward where inverse technology transfer becomes possible. But certainly there's an enormous amount of technology transfer into the discipline, and that's what is important to register here. So, thanks.
We're going to take about 45 minutes break for a quick lunch, and then regather and continue. Congratulations.